Day 440 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3202. Find the maximum length of a valid subsequence 2. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums and a positive integer k. A subsequent sub of nums with length x is called valid if it satisfies these conditions. So sub of 0 plus sub of 1 mod k is equal to sub of 1 plus sub of 2 mod k, and so on all the way up to it equals sub of x minus 2 plus sub of x minus 1 mod k. Return the length of the longest valid subsequence. All right, y'all, that sounds simple enough. And if you've been following along with this channel, we did find the maximum length of valid subsequence 1 yesterday. So I would suggest you go check that out before you get into this problem. But with that being said, y'all, let's get into these examples. Now, the first thing we want to do when we get into these examples is we want to understand what is a subsequence. So it says a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So now that we understand what a subsequence is, let's take a look at these examples. So in example 1, we have the input nums equals an array of integers 1, 2, 3, 4, and 5, k equals 2. The output is 5. Explanation says the longest valid subsequence is the array of integers 1, 2, 3, 4, and 5. So that's the whole array right here. So let me copy and paste this over here so y'all can see what is exactly going on, right? So we want to satisfy these conditions right here, and in this case, k equals 2. So to do that, this is what it would look like. So we'll take sub of 0 plus sub of 1, boom, this right here. So that would be 1 index 0 plus index 0 plus index 1. So that'd be 1 plus 2. Then we're gonna say mod k. So mod k, and that is going to be equal to 1, right? Because 1 plus 2 is 3, so 3 mod 2 is equal to 1. Right? So that's how we got this 1 right here. So now we're going to move on to the next sub of 1 and sub of 2 like it is right here. Boom. So sub of 1 and sub of 2 would be 2 plus 3 mod k. That's going to be 5, or in this case k is 2. So let's just change this to 2. Sorry, y'all. So that's going to equal 1 as well, right? So hold on, let me put up here k equals 2. Boom. So that's going to equal 1 as well. So that's what we want for our subsequence. So far this is our full subsequence right here. So that's 5 mod 2, that equals 1 as well. Boom. Then we come down here, we do the next one. We do sub of 2 plus sub of 3, right? So that would be 3 plus 4. Open up the parenthesis, 3 plus 4. That's mod 2. That's going to equal 1 as well. Boom, that's what we want. That's equal to 7 mod 2. That equals 1. That's what we want, right? So far, they all satisfy the condition. They all equal 1, right? When we go through these conditions. So far, everything equals 1. This equals 1, sub of 0 plus sub of 1 mod k, that's going to equal 1. Same thing with this is going to equal 1. Same thing with this is going to equal 1. And finally, let's do this, and as you already know, that's going to equal 1 as well. So 4 plus 5, sorry y'all, mod 2 is going to equal 1, so that'd be 9 mod 2. That's going to equal 1, right? So this mod just means the remainder. When we divide any of these, when we divide 3 by 2, that's going to have a remainder of 1. When we divide 5 by 2, that's going to have a remainder of 1. 7 by 2, remainder of 1. 9 by 2, remainder of 1. And since they all are equal to each other, they all equal 1, that's our whole valid subsequence right here. And we're not returning the subsequence itself though, y'all. We're just returning the count. And in this case, the count is 5. Boom. And that's how we got it, y'all. Because when we add the two sub of 0 plus sub of 1 and so on and so on, and mod k is going to equal 1. Boom. So let's take a look at example 2. And example 2 is pretty similar, but this time k equals 3. So we're going to be doing mod 3. So in this case, we have the input nums equals an array of integers 1, 4, 2, 3, 1, 4. This time k equals 3. Output is 4. Explanation says the longest valid subsequence is 1, 4, 1, 4. So as you can see, when we do 1 plus 4, that equals 5. Then we would mod 3, we'd have a remainder of 2. Then we do this, that's not going to work. That's going to give us 6. That will give us no remainder. So we could delete this 2. We could delete it. That's why there's no 2 in the output. Similarly, then if we did 4 plus 3, that'd give us 7. And we divide that by 3, that will give us a remainder of 1. So that's not going to work either because we're looking for a remainder of 2. So we could delete this 3 as well. Then we're just left with this 1, 4, and that'll give us 5 again, and that'll give us a mod 2. That'll give us a remainder of 2, sorry. And so as you can see, 1 plus 4 is 5. That's divide that by 3. That's going to give us a remainder of 2. 4 plus 1 is 5. Divide that by 3. That's going to give us a remainder of 2. 1 plus 4 is 5 again. Divide that by 3. Remainder 2. So since all of these will have a remainder of 2, and there are 4 elements that has a count of 4, so our output is 4. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult, nor is it that long, so let's get started. So we're going to be using dynamic programming for this. So to do that, we're going to create a 2D array of size k times k, and we're going to initialize it with zeros. And this is going to track the subsequence length where the previous mod k is equal to I and the current mod k is equal to j. So to do that, we're going to declare a variable, call it dp. We're going to set that equal to an array. Open up the parentheses, repeating, colon is going to be a 2D array, so it's going to be repeating arrays. Then it's going to be this array is going to be repeating, colon 0, comma, count up to k, come outside the parentheses, put comma, and we're going to do that same thing, count, colon, k again. Now we need to create a variable that will store the overall maximum subsequence length that we found, right? We need to create a variable to store our output. So for that, come right here, we could declare a variable. We could just call it, output. Sorry, y'all. Call it output, and we could set that equal to 0 to start. Now we need to iterate over each number in the input array. So we're going to say for num in nums. We're going to open up the brackets, and we're going to compute the module k value of the current number. So we're going to say let val equal num mod k. Boom. Then we're going to iterate over all possible previous module values. So for that, we're going to say for I in 0 dot dot less than k. We're going to open up the brackets, and we're going to update our dynamic programming table. If the previous mod was I, then we can extend the subsequence ending with the current mod val. So to do that, we say dp square bracket I, come outside of that, square bracket val equals dp square bracket val, come outside of that, square bracket I, come outside of that, and say plus 1. Just like that. And then we need to update the global result with the maximum length so far. So we're going to come right here, and we're going to say output equals max, open up the parentheses, output, comma, dp square bracket I, square bracket val. Boom. Then all we need to do is return the length of the longest valid subsequence found. So to do that, we could just come right here and say return output, just like that, y'all. And that should be all she wrote. Let's go ahead and give it a run. And it's accepted, so let's submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 145 milliseconds beats 100% of users. That's what I'm talking about. Those are some good numbers right there. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.